This facility processes over 6 tons of potatoes every hour, transforming raw tubers into 4.5 million. The journey begins at the receiving dock, where bulk shipments arrive throughout the day to maintain continuous production.
Each delivery contains thousands of pounds of raw potatoes, selected for their starch content and uniform size.
From this raw, earthy state, an intricate process will extract and reshape these potatoes into something entirely different.
The first stage, elevation to the sorting level, where quality control begins immediately.
Trained inspectors remove potatoes with green spots, excessive bruising, or irregular shapes that would compromise the final product.
The rejection rate remains low, between 3 and 5%, evidence of careful agricultural selection before they even reach this facility.
Inside the primary wash, high-pressure jets attack from every angle, while the drum's rotation ensures no surface remains untouched.
Field dirt, accumulated during harvest and transport, dissolves under the sustained assault of 55-degree water.
The separated contaminants drain away to filtration systems, while the potatoes move forward to secondary cleaning.
Rotating brushes, spinning at 400 revolutions per minute, provide the final mechanical scrubbing. Each potato is rotated through the brush field, ensuring complete surface contact and uniform cleanliness.
Optical scanners now take over, analyzing size consistency, surface quality, and using infrared.
The system processes 2,000 potatoes per minute, making split-second decisions with pneumatic precision. Only the acceptable specimens continue forward, now arranged in orderly rows, ready for transformation.
The peeling process uses superheated steam rather than mechanical blades, a technique that preserves more of the potato flesh.
Temperature climbs to 300 degrees Fahrenheit as pressure builds in the sealed chamber.
After 30 seconds of exposure, the sudden pressure release causes the moisture under the skins to flash to vapor, loosening them from the flesh.
Gentle tumbling in a rubber-lined drum completes the separation, removing the loosened skins through friction alone. The separated skins exit to become animal feed, and nothing is wasted in this facility. Here, Pringles' process diverges from traditional chip manufacturing. These potatoes will be sliced, but not into their final form. Each slice measures exactly 3 millimeters thick, precision that will prove critical in later stages. Random samples are pulled continuously, measured with calipers to verify the slicing mechanism maintains its tolerance.
Before they can be processed further, moisture content must be reduced from 75% to 40%.
Forced air circulation draws water from the surface, visible as the slices lose their glossy sheen and begin to mat.
This is Pringles' signature innovation. The dried slices are ground into flour with a particle size of 100 microns.
What emerges is no longer recognizable as potato, a fine, dry powder that flows almost like liquid. The formula is exact: 42% potato flour combined with rice flour for texture, wheat starch for binding, and maltodextrin for browning. 33% water by weight is added, and the mixture is blended until a cohesive dough forms.
The starches hydrate and bond, creating a workable dough from what was moments ago a collection of dry powders. Under immense hydraulic pressure, the dough is pressed and rolled into uniform sheets 4 millimeters thick. The tolerance is 1/10 of a millimeter. Any variation would result in uneven cooking and inconsistent texture. Multiple roller stations work in sequence, each reducing thickness gradually to prevent tearing or density variations. The sheets now rest for 10 minutes at 72 degrees, allowing the dough to relax and reach optimal moisture distribution. This patience prevents the dough from fighting back during cutting, yielding cleaner edges and less waste.
1,200 chips per minute are cut from each production line. The dies strike in hypnotic rhythm, punching out the iconic shape.
Each die is machined to exacting specifications, ensuring every chip begins as an identical blank. The dough between the cuts doesn't go to waste. It's collected and returned to the mixing station. 15% of each batch is recycled this way, maintaining an 85% yield from sheet to finished chip. Now comes Pringles' engineering breakthrough, transforming these flat blanks into the distinctive saddle shape. A hyperbolic paraboloid, a mathematical curve that's both structurally strong and allows perfect nesting when stacked. The dough holds this shape even after the mold releases, locked in by the precise moisture content achieved earlier. The consistency is absolute. Every chip receives an identical curve, essential for what comes next. The formed chips are positioned carefully in mesh baskets to ensure even oil contact during frying. Already, you can see how the saddle shape allows them to nest together, a preview of their final arrangement in the can. The baskets descend into 375-degree oil, the most dramatic transformation in the entire process.
Contact with the oil is instant and violent. Moisture flashes to steam, bubbles erupt from every surface, and the Maillard reaction begins.
In just 11 seconds, the chips expand slightly, firm into their final structure, and develop their characteristic golden color.
Multiple baskets flow through the fryer continuously, each spending exactly the same time in the oil. As they emerge, 98% of the oil drains away, filtered and recycled back into the fryer system. As they emerge, 98% of the oil drains away, filtered and recycled back into the fryer system. Forced air removes what drainage cannot. Rapid cooling would cause thermal shock and texture changes. Instead, temperature.
As they cool, the surface texture crystallizes and the color deepens to its final shade. No longer changing, just stabilizing.
The tunnel stretches long enough to ensure every chip exits at the exact same temperature, ready for seasoning.
40 different global flavors are produced in this facility, each requiring its own seasoning blend and dedicated equipment.
From simple salt and natural flavors for original, to complex blends of spices, dried vegetables, and flavor compounds for specialty varieties.
The chips tumble in rotating drums, while seasoning is dispensed in precisely timed bursts from overhead hoppers.
The target is 2.3% of the chip's weight, enough to deliver flavor without overwhelming or clumping.
The tumbling action ensures the powder finds every surface, every ridge, coating each chip uniformly.
Excess powder that doesn't adhere falls through the mesh and is collected. Again, nothing wasted.
Some flavors create dramatic visual transformations. BBQ chips enter golden and emerge deep reddish brown.
The coating follows the chip's geometry perfectly, settling into valleys and clinging to peaks.
Samples are pulled from every batch and weighed to verify the seasoning application rate remains within specification. Under magnification, any bare spots or clumping would be immediately visible. Neither is acceptable.
Automated optical inspection screens 3,000 chips per minute, checking for over-seasoning, under-seasoning, or physical defects. Defects are ejected with a precise puff of air. Rejected chips are ground and used as animal seed.
Approved chips now enter the counting and organizing system. Each can must contain exactly 56 chips. Optical counters track each chip as it passes, organizing them into precise groups for canning.
The target weight is 158 grams. 56 chips achieves this with minimal variation.
The stacking process requires absolute precision, and it begins with a single chip positioned at the base.
Each subsequent chip nests into the one below, the hyperbolic paraboloid curve cradling the previous chip perfectly.
This is why the shape matters. Any other geometry would create gaps or pressure points that would crush the chips.
Multiple stacking stations operate in parallel, each building its tower with identical precision.
The fit is so precise that the stack becomes self-supporting. No clips or spacers required.
Before canning, human inspectors verify stack height, chip orientation, and structural integrity.
Laser measurement confirms the stack height matches the can depth. Too tall or too short would be rejected.
While chips are being processed, their containers are manufactured in a parallel production stream.
The iconic cylindrical tube is formed from composite paperboard with an aluminum lining for moisture protection.
Steel bottom caps are seamed to the tubes, creating a rigid base that can support the weight of stacked cans. Labels are applied with precision alignment. The Pringles logo must face forward at the exact same position on every can.
The finished cans move in orderly rows to meet the chips they'll contain. Timing is critical to maintain production flow. This is the most delicate moment in the entire process. 8 to 4 cans are filled per minute, yet not a single chip can break.
The diameter of the stack matches the can's internal diameter within a fraction of a millimeter, and they slide together like a piston in a cylinder.
The final chip seats at the top, leaving just enough space for the lid to compress the stack slightly, creating that distinctive pop when opened.
Plastic lids are dispensed from hoppers and positioned with mechanical precision.
The pressing force is calibrated to compress the chips just enough to create a secure fit without crushing them.
But before the lid is fully seated, an aluminum foil seal is applied to the can opening. Heat sealing bonds the foil to the paperboard rim, creating an airtight barrier that protects freshness. The excess is trimmed away, leaving a perfect circular seal that consumers will remove before their first chip.
Just before the final seal, nitrogen is injected, displacing oxygen that would cause the chips to oxidize and go stale.
Every single can is weighed. The target is 158 grams, plus or minus 2 grams. Can after can registers within specification. The counting and stacking process is remarkably consistent. Seal integrity is tested next. Each can is subjected to slight pressure changes while sensors detect any leaks. Failures are rare, but when detected, the can is immediately diverted, opened, and its contents returned to the process.
Metal detection is the final safety screen, sensitive enough to detect a single staple, ensuring no foreign objects reach consumers. Individual cans are now grouped into the multi-pack configurations retailers order: 2-packs, 4-packs, and display-ready 12-packs.
Shrink wrap holds smaller multi-packs together while displaying the product clearly to consumers. Larger packs receive rigid cardboard dividers that protect cans during shipping and double as retail displays.
Robotic arms work in perfect coordination, placing multi-packs into shipping cases without collision or hesitation.
Cases are palletized in alternating patterns, each layer rotated 90 degrees from the one below for maximum stability.
Multiple palletizers operate in parallel, each building perfect stacks 40 cases high.
The completed pallets now require protection for their journey. Stretch wrapping secures them for shipping.
5 layers of stretch film are applied under tension, binding the stack into a single weather-resistant unit.
What began as individual cans is now a secure shipping unit ready for distribution anywhere in the world.
Final inspection verifies wrap integrity. Any tears or weak points could compromise the load during transport.
Pallet labels contain shipping information, destination codes, and tracking numbers, complete documentation for the distribution network.
The warehouse holds 2 million cans at any given time, roughly 12 hours of production, awaiting distribution. A computerized inventory system tracks every pallet by location, production date, and destination. First in, first out.
As orders arrive, pallets are retrieved and loaded onto trucks bound for distribution centers across the continent.
Each trailer holds 20 pallets, 480 cases, 11,520 cans.
From this facility, Pringles reach 140 countries, grocery stores, convenience stores, vending machines, anywhere consumers look for them.
This is what emerges from that industrial process, a single can, containing 56 perfectly uniform chips. The cylindrical container protects its contents while becoming instantly recognizable. Form follows function, but creates iconic design.
Opening a can of Pringles is a multi-sensory experience. The pop of the lid, the peel of the foil, the distinctive sound.
And there they are, stacked with such precision that none have shifted or broken during their journey.
The hyperbolic paraboloid curve is immediately apparent, a shape that began as mathematical theory and became snack food reality.
Even out of the can, the chips maintain their nested relationship. The engineering precision extends to the final consumption experience. This curve, simultaneously concave and convex depending on the axis, provides structural strength without requiring additional thickness.
The thickness is uniform from edge to edge, evidence of the precision sheeting process earlier in production.
Seasoning follows the topography of the chip, settling into valleys while coating peaks, ensuring flavor in every bite.
Over 40 flavors worldwide, each with its own color signature, yet all sharing the same fundamental geometry and production process.
The balance between strength and delicacy is precise, strong enough to stack without breaking, delicate enough to shatter satisfyingly when bitten.
The final test of all that engineering and precision, the consumption experience.
From raw potato to finished chip, a journey through steam, grinding, sheeting, cutting, forming, frying.
Each can represents the culmination of engineering innovation, manufacturing precision, and quality control. Each can receives a best-by date, batch code, and production timestamp, complete traceability from potato to shelf.